section 2 is properties of radicals. So we're going to look at 2 properties, and then a big part of this section is just simplifying, seeing what you can pull out from underneath radicals to get it into its simplest form. Okay, so the first property, it's just written algebraically. So you're going to take the nth root of AB, and one way to simplify it is to break it up, to say the nth root of A times the nth root of B. And this will be beneficial because you can separate, bless you, the number that's under the radical or the algebraic expression so that it'll match your power. Okay, bless you. All right. The second property is the nth root of A divided by B. Bless you. And that can also be separated to the nth root of A over the nth root of B. Okay. These are just 2 properties that'll help you simplify. Okay, get those radicals as simplified as you can. All right. So example number 1, we're going to take the square root of 98. Okay. If it doesn't have a root number, you always assume there's a 2 there, right? We don't normally write second root like that, but that's what a square root is saying, right? So is 98 a perfect square? It is not, right? But are there any perfect square factors of 98? 49 is one. So we're going to use this first property, which says we can separate it to the square root of 49 times the square root of, what was that, 2? Yeah. Square root of 2. So then you just take the square root of 49, you get 7, and then 2 does not have any perfect square factors, so we just write the square root of 2. Any questions on example 1? Okay. Example number 2. Also with the square root, we're going to take the square root of 4/9. Both perfect squares, but we're using the second property, which says that we can separate them to the square root of 4 over the square root of 9. Square root of 4 is 2, square root of 9 is 3. Any questions on example 2? All right, now let's try one that has a different root other than just 2. Okay, so example number 3. Third root of 25 times the third root of 10. Is 25 a perfect cube? It's a perfect square, but is it a perfect cube? No. How about 10? Is 10 a perfect cube? No. So we're actually going to use this first property backwards. We're going to multiply those 2 numbers that are under the radical, and we're going to rewrite this as the cube root of 250. Now, are there any perfect cube factors of 250? I'm asking because there is. Anybody know it? 125. So I'm going to rewrite this as the cube root of 125 times the cube root of, and what would I multiply 125 by to get to 250? 2. Okay? So I can take the cube root of 125, it's 5, and then the cube root of 2 does not simplify. Okay? So we can't do anything with it in this form, but we can, once we multiply it out, then we can simplify. Okay? Any questions on example 3? All right. Example 4. cube root of 81 over 8. So first thing we want to do is use that second property where we separate to the cube root of 81 and the cube root of 8. Then we have a radical in the denominator. No, so when we're done, we just need to make sure there's no radical in the denominator. How about the numerator? Is that okay? Yeah, okay. How about 81? Is 81 a perfect cube? No, but how can we write 81 so that it has an exponent? Like 9 squared? How about another way? What else? What other number would get us to 81? If 9 would get us to 81, what other? 3, right? So we're going to write this as the cube root of 3 to the what power? 3 to the what power is 81? To the 4th. Okay? And then the denominator is kind of easy. Is there a cube root of 8? Yes, it's just 2. 2 times 2 times 2. So we pull one of them out. Okay? Now, this numerator, is there a cube factor in here? Yes, because 3 to the 4th is really 3 to the 3rd times 3 to the 1st. It's both of them, right? So we can take the cube root of this, but we can't take the cube root of this. Does that make sense? So this 3 is going to come out, and then this 3 has to stay under the cube root. Okay? This 3 to the 3rd, that 3 came out in front. This 3 to the 1st power has to stay under the cube root, and then the denominator is 2. Okay? Check and see. Sometimes you'll be able to reduce. In this case, you can't. Okay? Any questions on example 4? Yes? Because we want the 3rd root, so anything to the 3rd power is what would come out. So if it was 4 times 4 times 4, we would take out 4. Or if it was 5 times 5 times 5, we would take out a 5.
If there was like a cube root, would you read squared?
I'd have to, I'm not sure what you're saying. Write it down, and then I'll come look at it and tell you what to do with it. That's probably the best way to deal with that. Any other questions on example 4? All right, example 5. We're taking the square root of 2a squared b. Sometimes you can only take out part of the expression. For instance, this 2 has no square root, but the a squared has a square root of just the a, and the b does not have a square root. So the 2 and the b stay under the radical. That one's almost too easy after the one we just saw. All right, example 6. Cube root of x to the 5th over y to the 3rd. Grace, I wasn't going to expand this one out, but I'll expand this one out, and then maybe it'll help you with number 4, okay? So under the cube root, we've got x to the 5th. So x to the 5th is x times x times x times x times x. We want the 3rd root of that. That means we need something that's being multiplied 3 times. This is being multiplied 3 times. So x will come out from underneath that cube root. These other 2 this x squared will stay under the cube root because it's not a cube root, it's only a square root. Okay? Same thing with the denominator. The denominator has a third root of y times y times y. And there's 3 of them, so we want the cube root, so the y will come out. And we didn't end up with a radical in the denominator, so we're okay there. Okay? Finish copying that down.